Hey, this is Mr. Mitchell. We're going to talk a little bit about some changes, physical and chemical. Here are the questions. Go ahead and write them down. What is the difference between a chemical change and a physical change? If you have a chemical change, you actually have substances that are, well, changing. Um, you chemically start out with different subjects than you end up with. For example, here we have a lighting of a match. The lighting of a match is a chemical change. By doing the lighting, you actually take off this red tip, and substances from there end up turning out to go into the air as gas. Sure, you still have some wood left. Sure, you still have some burnt wood left, but you actually have a change of just a solid here into solid and some gases. You actually have physical change, an actual change of the chemicals. Here's another example of a chemical change. This is an antacid that is dropped in water. Now, one of the signs that you might have a chemical change, because sometimes you can't tell, is bubbling. And what's happening here, you had this solid that was dropped in the water. And after the solid was dropped in the water, these bubbles started coming up. It started releasing gas into the air. Now, every time there's a chemical change doesn't mean that gas is released into the air like in these two cases, but you often do find that sometimes you have a color change. Sometimes you have a different odor, like rotten eggs, maybe a temperature change. Several things can indicate that you actually have different chemicals or a different change of substance whenever you have a change. Now, how does that compare with a physical change? Well, a physical change doesn't change the substance, even though it goes through changes. And I'm pointing here to this little lamb here, or this sheep. And the sheep, as you can see, has lots and lots of wool. Wool can change a lot. It's on the sheep. You can shear it off the sheep. It can be spun into yarn. It can be dyed. It can be on you as a sweater. But in all these forms, it's still wool. It is wool. It does not change. That is an example of a physical change. Even though it went through definite changes, it is still the same substance. That's the primary difference between chemical and physical changes. Pardon me while I go to another slide here. Speaking of physical changes, whenever we change from solid to liquid to gas, all those are physical changes. These are the three different states of matter. Now, there's actually a fourth one called plasma. I'm not going to get into that right now. But these are the ones that we are familiar with more here on Earth. And probably the simplest example would be water. Here we have water in its regular state, but if you make it cold enough, it will be a solid. And if you make it hot enough, it can disappear into gas. Now, this gas is visible here, but we know that as you look around, there's actually water in the air that you just can't see. But the whole key here is going to be temperature. Temperature is going to be what changes things from solid to liquid to gas. The temperature is going to be the key. Now let's take a look down here. Here we have some more characteristics, some obvious characteristics of a solid. We have all the molecules in the solid that are in a confined space. They're in a confined space. However, all these particles are moving. Yes, even the pencil that you're holding in your hand, the computer that you're in front of, the molecules are actually vibrating in there. And I think we mentioned that in another video. It doesn't appear to be, but it actually is. And throughout, what happens is the more temperature you give a substance, at some point it will turn liquid. The vibrations will be a little bit more not necessarily noticeable, but you have more movement amongst the molecules. Now, it didn't change the matter. I mean, you still have the same number of molecules. It's just that it can be in uh, a less confining space. If you were to drop some dye into this liquid, it would eventually disperse out because these water molecules are continually moving. And if you add more heat, then at some point it will turn into gas. Now with water, once you got above 32 degrees, that was the, I guess you'd say, the melting point of the solid, and it became liquid. And once you get to about 212 degrees, that's when you start getting the bubbles and the evaporation a little bit more uh, obvious. Now you see here the gas is going to take its container size. It's still going to have the same amount of molecules. It's just that it is expanded out. So you have less movement of the molecules in the solid all the way to more movement of the molecules in the gas. And it all has to do with the temperature. Now some things at 32 degrees are going to stay solid. Most every substance has different degrees at which you have a melting point or a boiling point. So everything is not going to be scalded at 212 degrees and frozen below 32 degrees. It depends on the different object. Speaking of liquid, let's talk about viscosity. Your book is going to have the term viscosity in it. It's the amount of attraction between the particles in a liquid. And the example they're going to give is the difference between honey and water. Honey is a lot thicker in flowing. It has more, there wants to be more attraction to the molecules want to attract each other, and that's why it's so very thick. So the one that has less viscosity would be the honey. The more viscosity, the easier it flows over itself. So water would have more viscosity than honey would because it flows over itself more. Just kind of wanted to tell you about that. Okay, let's talk about changes of state a little bit more. We talked about how the solid particles are vibrating anyway. And the hotter a solid gets, the more movement these particles have. And at the melting point, whatever solid it is will turn into liquid. Sure, even the pencil you have, at some point you give it enough heat, it will end up having liquefying characteristics. The computer you're sitting in front of will have liquefying characteristics. It's just going to be at a lot hotter degree than 32 degrees is. All particles will be able to change state depending upon the temperature. And like I said here, it's the more heat you have, the more evaporation of that water you have. And here you can actually see some what appears to be water molecules a little bit easier to see in the air. At the melting point, these vibrating particles break loose and slide past each other. Now, evaporation is the process of how liquid becomes a gas. The faster moving molecules of liquid, are the first ones to become gas, so it doesn't all make a complete 100% change. The faster moving particles are going to become gas first. Kind of the same thing here. The faster moving solid particles will become liquid first. If you hold an ice cube in your hand, it will start melting, but not 100% all at the time. You'll have some that will melt quicker than others. Take a look at this next slide. Talked a little bit about evaporation. Condensation is kind of going back from mist into the liquid. Condensation, you probably heard this back in the 6th grade, but this is how it happens. You have the warm air and the cold glass. The air right around this glass is going to be colder than the air around it. And cold air just does not accept moisture like warm air does. You know, it's all about temperature. If you end up getting a warmer temperature, it has more moisture in the air. So what happens whenever this warm air becomes cold right around this glass? Well, it has to drop its moisture, and that's what you see on the side of the glass. That's the condensation. Clouds are a condensation, made from a condensation process as well. You have the colder air, the warmer air that suddenly becomes cold and has to form something. So that's why clouds are up in the atmosphere, because that's typically where you'll find that big change of temperature. Now there is something called sublimation. And here's an example of sublimation right here. Sublimation is when under certain conditions a solid can convert directly into gas. An example we have here, I believe this is dry ice or liquid nitrogen. I forget which this one happens to be. But you can see that this, we don't have the liquid there. It is just going under room condition. It's going straight into the gaseous state. Going straight into that gaseous state. And that's what sublimation happens to be. Looking in my notes to see if there's anything I have forgotten. And I don't think there is. So make sure that you complete all these questions. I hope you've learned a little bit about these states of change of states.